Well, good afternoon, everybody. First off, I want to thank you, Philip, for the introduction. I actually feel really honored and privileged to be here today doing this talk for you. So I've done a few presentations, a number of presentations in the past, but this is actually going to be my first keynote. And in particular, I found this one to be actually really difficult to prepare for. And the main reason for that is some of the things that I'm going to be talking about are a little bit controversial in today's day and age. It can be a little bit uncomfortable to talk about things like the apocalypse or the AI testing apocalypse or robots taking over. So hopefully you get something out of this presentation. My goal for this presentation is for everybody here to be able to learn something, for everybody here to be able to walk away with something actionable that we can take back and we can hopefully make sure that we survive this thing called the AI testing apocalypse. So a little bit about me. So I do work at Ultimate Software, been there for about 10 years now. And in the time that I've been there, I've been in a number of different positions. I started as a software test engineer where I worked on a variety of different teams, different products, testing the products. Then I became a team lead working on testing tools, and then eventually became a test architect, spent doing that for a few years. And I'm currently the principal quality architect where I focus on a lot of research actually in AI and ML and seeing how we can potentially apply some of this stuff to testing so that we can benefit as a company and as an industry. I'm also a PhD student at Florida International University where I'm studying essentially the intersection between AI and testing. And I recently completed my master's with a thesis in the same area, specifically around leveraging AI for test generation. So let's talk about surviving the AI testing apocalypse. So apocalypse is a pretty strong word, right? So what exactly does that mean? So apocalypse is an event that involves destruction or damage at a catastrophic scale. And I'm sure we've all seen examples of this. There are many different types of these so-called apocalypse. And one that comes to mind very quickly is just some kind of disease, some kind of virus, a contagion, some kind of runaway epidemic. Maybe the vanishing apocalypse, where some humans get suddenly taken away and some of us get to stay back and chill out here for a while everybody else is doing God knows what. Then there's the alien apocalypse or alien abduction apocalypse. So how many of us here have seen the Alien trilogy or all those movies? Not me, actually. So I've actually been told that one of the things I should do after this keynote is go watch those because those are really good. So the zombie apocalypse, I'm actually an avid gamer. I love gaming. Resident Evil is one of my favorite games. So seeing this kind of stuff is really, it's just another type of apocalypse, one that I actually happen to believe is possible. Then there's the nuclear, some kind of nuclear apocalypse, or maybe some kind of like massive storm, some kind of, natural event or natural disaster that can, cause an apocalypse. And this is getting kind of grim, I know, right? It's getting a little scary. But there's actually one more. I actually forgot what it is. Let's see if the slides know. So there's one more. And that's this idea of the robot apocalypse, right? Or the rise of the machines, the robots taking over. So you're telling me that I have to worry about being abducted. I have to worry about catching some kind of disease, some plague. I have to worry about zombies. And now I also have to worry about the machines? Aren't we the ones that are building these systems? So why do I have to worry about this? Well, it turns out that yes, we absolutely need to worry about the machines that we're building. So actually, at this very conference here, my colleague and mentor, Dr. Tariq King, gave a keynote here last year titled The Rise of the Machines. And what he talked about was the fact that AI is actually disrupting a lot of the industries that are out there, and the fact that testing is also possibly going to be very disrupted. Testing as we know it today, anyways, is possibly going to be disrupted by AI. So I think it's really important for us here, and I think one of the two fears that kind of come about when you think about AI and when you think about machine learning is really, the first is hashtag no more testers, right? So yeah, I mean, that's basically, can the AI get so good that it can actually replace our job function as testers? And that's a really big fear, and I think it's important for us to be exploring this and seeing what AI is capable of. But there's an even bigger picture here, and there's an even bigger fear at play, and that's hashtag no more humans, right? So yeah, the AI may get strong enough, it may get good enough that it can do a lot of the things that we do as testers today, and that's scary in and of itself because we might have to adjust. But when you really start to think like higher level than that, and you start to think about killer robots on the street, it gets even scarier, and it becomes a more serious topic, I think. So I want to share a video with you that I think is really relevant for this. So there's a lot to unpack about that video, and there are lots of different messages and opinions. But I think one that really stuck out to me was this whole thing about the ants, right? The ant hills. We don't hate ants, right? Just to recap from the video, we don't hate ants, but we have a goal. And if our goal is to build a road, then goodbye anthill, right? So that's, when you really think about that for a second, right? And think about the fact that if humanity is able to create superhuman intelligence, we're the anthill, right? So it's really, the implications are quite large. So it's really frightening when you start to think about this, and when you start to think about AI and machine learning and all the different advances, and you start to peel the onion and you see all the things that are happening. So with all of that in mind, I want to talk about survival. And I want to talk about survival at multiple levels. I'm actually in the camp that believes that if we actually succeed at creating this type of intelligence, that it'll be our last invention. It'll be humanity's last invention, and that's really scary to think about. So today I'm going to tell you a tale of survival, and not just survival as testers, but survival as humanity, right? Survival as civilization. But first, I want to take a step back, and I want to talk about AI, and I want to talk about ML, and I want to share with you some of the recent advances, some of the recent really cool things. Not so scary things, there's some scary things, but some really cool things, because I think it's really exciting technology. Despite all of this fear and all of this thought of the machines taking over, I actually am really impressed and awed by this technology, and I think there's a lot of good that can come from it, and a lot of good that is already coming from it. So I want to share with you some of that, so that you can have your own judgment, so that you can form your own opinion on where we are, where we came from, and where we might be headed with this technology. So the reason that I'm really excited about AI and ML, I'll give you a little bit of backstory about myself. So there were two really interesting career-defining moments for me. The first was when I saw test automation running for the first time. This is just Selenium stuff, like your technology that's been around for what feels like 100 years probably to some of you. But when I first saw test automation running, I actually started at Ultimate Software wanting to get into software development, and that changed my mind because I was like, this is really cool stuff. This seems like magic. Like, how is it that this system can actually do this type of testing automatically? But it actually wasn't magic, right? It was just some software that somebody wrote. I don't want to downplay it. It's a lot of effort that has gone into it. But it's just following basic instructions like any other computer program. So it's not magical. So that was the first kind of moment. The second moment was when I stepped into a self-driving car. Now that seemed like it was magical, right? Because that's not just code, that's AI, that's machine learning, that's you can't even debug these type of systems very easily. You can't see the code. You can't see why it's doing what it's doing a lot of the times, right? So that felt like actual magic. Like that felt like this is really scary, actually. Like this is magical, it's awesome, it's useful, this is super cool, but at the same time, machines should not be doing this stuff. It doesn't make sense. So when I really think about these two moments, it's really no surprise to me that I am as obsessed as I am with AI and machine learning, because it's such an exciting technology, and it can do these things. It can self-drive a car autonomously. So there's real hope and excitement. And while this presentation is going to talk about some things that are scary and is going to question whether or not the machines can take over, I also hope that there's an undertone in this presentation of hope and motivation and understanding of what this technology is, so that we can actually embrace it and not be completely scared of it. So let's lighten the mood a little bit. So the first thing I want to talk about is AI, right? So for those of us who have not, maybe are not completely up to date with all of the happenings in AI, I'll start with baseline example. Real simple. Simplest AI I can probably think of right now is you give it a picture of a dog, input, output comes the breed of the dog. So we can build these systems today. They already exist. And computer vision has actually been around for quite a long time. Not like AI and ML is helping computer vision, but computer vision was already around before AI and ML, right? It's just that computer vision has enjoyed a lot of benefits from the advances in machine learning. So this is really cool. This is cool. We can take these dogs, we can take these pictures, and we can classify them. But did you know that AI can also create music? So up until now, maybe kind of your worldview is, yeah, all this AI stuff, it's really good at learning how to solve specific problems, but it lacks creativity. And humans bring the creativity aspect. But this is an example of AI that's actually showcasing creativity as well. So it's been trained. This is actually from OpenAI. You can go on their website. You can actually check this stuff out. You can run it for yourself. And they actually trained this AI by just showing it examples of music. Nobody sat down and said, hey, these two instruments sound good together. You should make music with these two instruments. The AI figured it out on its own based on the training data that they provided it. So let's actually take a listen here. Okay. So yeah, fully generated by machine learning. Really cool. What else do we have? So there's also a lot of applications of AI for natural language processing. So we can take text, we can do text-to-speech, we can do language translation, sentiment analysis, and then we can even generate text. So there's AI out there that can take classical texts like Alice in Wonderland and generates new writing. It's almost like if the author wrote that writing, and it's almost like it was part of the original book or the original text. But actually, to take that even further, OpenAI is also doing some stuff with code generation. So here's an example of an AI that's been trained on millions of lines of code from GitHub, and it's actually helping the programmer write the code. And it's not basic recommendations like you would get from your IDEs today. It's recommendations that involve semantics and recommendations that involve context. So the AI has been trained on these types of functions, and it says, hey, the developer is writing a concatenation function that takes two strings and puts them together. I know I've seen something like that before. So it actually provides code completion that gets the job done. So this is actually AI writing code for us. So how far away do you think we are from having these systems write our programs for us, I don't think we're super far anymore. It surely seems a lot closer than we think it might be. What about gaming? So this is actually DeepMind. So I'm sure you've heard of DeepMind before, maybe AlphaGo. Does that ring a bell? So this is AlphaStar. And AlphaStar uses reinforcement learning, which is one of the more complex algorithms in deep learning, or in machine learning. And what it does is that it's basically an agent that gets put into an environment. In this case, the agent is AlphaStar, and the environment is StarCraft 2. It's a video game. And what it does is that it takes actions in this environment, and then it gets rewarded or it gets penalized based on those actions. If it was a good action, it receives a small reward. If it was a bad action, it receives a penalty. And over time, these systems, it sounds really easy in theory, but it's actually some of the more deep research in AI is in this area of reinforcement learning. But it actually learns by itself over time how to play the game. And in this particular kind of video screenshot here, screen cap, AlphaStar is playing almost kind of like at a human professional player level. And it even, I don't know if you caught this, it's not showing right now, but in the beginning of the match, the AI actually wrote to the chat window, "Good luck, have fun," to the opponent. And the human player didn't even say anything, so it's even showing emotion, apparently. Okay. So here's an example of something called distributed learning. So this is actually in a lab that Google has. And they have all these robotic arms. And the task of each one of these arms is to grasp some object. And it uses reinforcement learning to get better and better at grasping random objects. Now, the cool thing about this is that actually reinforcement learning is a slow process. It requires a lot of training. It requires a lot of iterations. But what Google is doing is they're actually doing distributed reinforcement learning. So they're taking the knowledge and the experience from all of these arms together, merging it, and then every day they're releasing a new version of the model so that all the arms actually get better together, and they learn from each other. So that's really cool. What about self-driving cars? So this can't be new to anyone here. I mean, we've all seen all this news on self-driving cars, but did you know that Waymo, which is a subsidiary of Alphabet, is actually already putting these cars in production? Like, there are some self-driving cars in some areas of Arizona that are in production today, that are actually picking people up and taking them to places with no human driver at the seat. And that's actually really interesting, really impressive. So what about so self-driving cars are definitely useful. What I want to talk about next is applications of machine learning in the medical field. And this one in particular is a recent kind of discovery, recent research that looked at trying to diagnose, forget the name, diabetic retinopathy. Yeah, that's the one. So if you're diabetic, then it's recommended that you get screened every year for a possible degenerative disease that kind of can potentially make you go either partially or fully blind. And there aren't many people in the world that actually have the training required to be able to make a diagnosis like this. There are people, but they're very scarce, and in some countries, there are not a lot of them. So people don't get the routine checkups that they need to get in some cases. And the good thing, if there's a good thing in this story, is that if you actually catch this disease early, it's preventable. It's something you can manage, and you will not actually suffer those consequences. But we've actually got research that was able to build, a team was able to build an AI that performed just as good as the experts in the field that can take a visual eye scan, or an eye scan, and can tell you whether or not, with a really high degree of certainty, whether or not you are developing this disease. And it actually does a really great job at it. And this is really interesting. But if you go back to the dog example, it's kind of like the same thing, except this is actually useful. Where you take an image and then you have an expert provide some information about that image, like, hey, yes, there is some sign of this disease in this image, but not in this one. And eventually the AI gets better and gets really good at it. But there's something that happened here in addition to that. And that is that it's actually possible to predict somebody's age, somebody's diastolic pressure, somebody's risk of cardiovascular disease, somebody's sex, from the same visual eye scan. And nobody actually knew this. This was not something people knew, but the AI actually figured it out on its own. And it actually told us that. So this is an example, if you actually read the paper, where not only did we teach the AI how to do something, but then it taught us something in return. So that's really interesting. So I want to talk about the emerging technology hype cycle. So if you think this stuff is going away, it's definitely not. This was released in August of this year by Gartner. And what they show is that actually a lot of the emerging technology has to do with artificial intelligence. So there's things like emotion AI. So how do we build AI that deals with human emotion or can detect human emotion? There's research on generative adversarial networks, transfer learning, explainable AI, and the list goes on and on and on. I know this is a little hard to see, but there's a lot of AI stuff there. So this picture in the back here is Dr. Andrew Inge. He's actually one of the pioneers for deep learning, which is one of the kind of like the areas that's seeing a lot of advancement lately in this space. And he's doing a lot, and he's done a lot to actually propel this technology forward. He actually has 3 startups going right now. One is called AI Fund, which funds other AI startups from scratch. He's got Landing AI, which helps companies actually start using AI in their companies. And then there's also deeplearning.ai, which is kind of like a teaching branch where you can go and learn about this stuff. You can go and sign up for these courses, and basically it's self-learning at your own pace. So all of this that I've kind of shared in the last 10 minutes or so tells me, beyond the shadow of a doubt, a few things. It tells me that AI is here. AI is not something that is going to be here 5 years from now. It's something that's knocking on our doors today. It's everywhere. We're starting to see it in so many industries. I just gave you 7 examples, if you were counting. 7 examples from 7 different industries where AI is being applied today. It's important. We're enjoying a lot of benefits from this technology. Self-driving cars are useful. Medical diagnoses are even more useful. So it's really important, and it's not going anywhere. You saw the emerging tech hype cycle from Gartner that's showing that a lot of the research and new technology is in this space. So it's not going anywhere. And I really see only one way forward with this technology, is that it's only going to keep growing, and it's only going to get stronger. And I think when you see videos like that video where Elon Musk was saying, yes, this super intelligence is definitely going to happen in our lifetime, it's a little bit more believable when you actually see some of this stuff and when you see some of the progress that is being made. And just in case you're a skeptic that AI is somehow going to penetrate every industry except the testing industry, I want to remind you of some of the companies that are doing fantastic work in this particular intersection. These companies actually have products today that are starting to propel us and our organizations away from writing scripts using tools like Selenium and spending a lot of time writing test cases manually and spending a lot of time writing automation and maintaining it. And they're propelling us towards a future where automation is codeless. Automation is self-healing in the presence of test flakiness. And automation is even autonomous in some cases where you don't even have to write the script. You give it your application and it will automatically explore the application and maybe find some defects. So it's definitely here in testing as well. And it's going to continue growing everywhere, not just in testing. So I want to share this quote also from Dr. Inge, where he actually believes that AI is the new electricity. And he says, just as electricity transformed almost everything 100 years ago, today I actually have a hard time thinking of an industry that I don't think AI will transform in the next several years. I also want to share a second quote by Geoffrey Hinton, Dr. Hinton. If you don't know Dr. Hinton, he is considered by a lot of people in the field to be the modern, kind of like the godfather of modern AI. And last year, he won a Turing Award, along with Yoshua Bengio and Yann LeCun, for their work on deep learning. And this is what he has to say. I think we should think of AI as the intellectual equivalent of a backhoe. It will be much better than us at a lot of things. So, this tells me that AI is real. It's definitely real. It's also scary. And it's very possible that if we don't do something about it, that we might get left behind as a civilization, not just in testing, but outside of testing too. So really, there's one question that we need to start talking about at this point. Could we survive? That's the fundamental question. Nobody actually knows the answer, because as far as I'm aware, nobody can predict the future. So nobody knows how much AI is actually going to take over and how much it's going to affect us. But I know that we can give it our best shot. So we know that this thing is coming. We know that it's already here, actually. We know that it's going to get better. We can give it our best shot. Humans have always been good at adapting. Humans have always been good at evolving. So there's no reason that we shouldn't give it our best shot. And after all, we're the ones that are building this stuff, right? So we should have direct control over it. We should be able to build it in a way that it doesn't take us over. Or can we? But while I do believe that the technology can maybe one day surpass human intelligence, I don't think it's any different from some of the things we've seen in history. I think that we've gone through a number of phenomenons like this, 3 industrial revolutions, and at every step of the way, we've always found a way to adapt. We've always found a way to evolve. We've always found a way where we're better at things than we used to be, and we shift in that direction, right? So I don't think it's necessarily any different. And I think we've got all the tools that we need to prepare for this AI apocalypse and to prepare for this AI testing apocalypse. So let's talk about that. So the first machine age, I just want to remind us of some of the machine ages. So the first machine age really was towards the end of the second industrial revolution. This is really when we started to see modern physics, the transistor, the first computers, the atomic bomb, the atomic age, and all this stuff, right? And the machines that we saw come out of that as a result were machines that complemented humans, were machines that did manual labor, manual type tasks, right? Handcraftship, automation. There are some people who think we're going through a second machine age right now, and this machine age is focused on not complementing humans, but actually substituting human activities, human tasks that require mental thinking, mental capacity, mental effort. So where the first machine age focused on replacing or complementing manual tasks, the second machine age is focused on mental tasks and substituting human thought. So what does this mean for testing? So this is what I think about when I think of testing. Does anyone disagree with me? So I think we're extremely overburdened. I think we have to release so fast nowadays, especially with continuous delivery, And there's so many different things that we need to make sure are working that we just can't scale anymore. We're already overburdened, and I think we need to do something about it. We need to find a way to scale. And I think that AI and machine learning can help us with this task. I think it's actually a blessing for us because we're already overburdened. We're pushing release after release after release. And I don't know about your companies, but at least at Ultimate Software, where I work, developers outnumber testers, in some cases, 10 to 1. So how do we actually stay ahead? How do we test all the different releases that need to go out? How do we make sure that the software is of high quality? It's getting harder and harder. And guess what? We're the first ones that they come to when a bug is found in production. Well, why didn't you catch that? Oh, I had 5 other releases to test. Oh, we just got to test harder. We got to figure out how do we actually test harder? How do we test faster? Get it out the door quicker, right? So I think that AI and machine learning, really and truly, if you think about it, is here to help us. So let me ask you a couple of questions. So what if the machines can actually replace some of the thinking that we do today? So what if it can actually generate some of the test cases that I have to sit down and write and automate and maintain today? I actually welcome the AI because I know that it's going to help me and it's going to free up my time to focus on more important things. Because believe you me, there are more important things that we need to start thinking about. And there are some things that I know AI is not going to be able to do today. Guaranteed. Like having instinct, having gut feeling, having intuition. You know that feeling when you're in a situation and you have to make a decision, and somehow you know the right decision to make. Like what is the right choice and what is the wrong choice. But you can't really explain it to yourself or to someone why you think those are the right or wrong choices. You just know. And that's your gut feeling. That's your humanity, your instinct coming out. Where you look at a situation and you say, something is not right here. So while I think the AI can do a lot of the things probably that we're doing today, it's not going to be able to do this kind of stuff. It's not going to be able, not anytime soon anyways. Maybe, unless there's some breakthrough. But not anytime soon. The human aspect of the human element of being able to apply your gut feeling and your instinct to testing and to everyday life is not something that AI is going to be able to do soon. So, if I can actually do this, if I can actually employ an army of AI bots, then I welcome it wholeheartedly because I think it can help, and I think it can help speed us up, make us more efficient, and we've got this. So I know that we're still going to be relevant. But there's an even bigger challenge that I'm going to be talking about in a few minutes. So let me lighten the mood once again. So I mentioned the whole zombie apocalypse thing. I would not be able to sleep tonight if I didn't make sure that you walked away from this presentation prepared to survive the zombie apocalypse. And also prepared to survive the AI testing apocalypse. So what I've done is I'm going to provide you tips for both. Okay? So the first step you got to follow here is to prepare a kit. All right? For the zombie apocalypse, it's real easy. You need a 72-hour kit that has basic essentials: food, water, iodine tablets, flashlight, batteries, you name it, your essentials. You got to have that stuff. What about for the AI testing apocalypse? Okay? I think you also need a kit, except this time it's a little bit of a mental kit. And what you need to put in this kit is everything we know today. All of our methodologies, all of our heuristics, all of the processes that we follow today to find defects. That needs to go in our kit, okay? All of the techniques boundary testing, equivalence, class partitioning, pairwise testing, finite state machines, all these things that you know you have in your tool belt, this goes into your kit. And you make sure that you have this readily available to you every step of the way. Moment's notice, you reach into your kit, just like your kit for the zombies. All right, step number 2. Keep in shape. For the zombies, you know what they say? In the zombie apocalypse, the number 1 rule is cardio, okay? When the ammo runs out or you get caught off guard, you have to be able to outrun the zombie or at least outrun the guy next to you, okay? So what does this mean for us here and for testing, the AI testing apocalypse? Keep in shape. The name of the game is cardio, once again, except it's mental cardio, if you want to think of it that way. And it's really about training, and it's really about seeing what's out there for AI and ML and actually starting to learn this stuff and starting to apply this stuff yourself and practice it as much as possible. I really recommend that if you haven't done so already, there are so many resources out there, and I'm going to share a few of them. So there's a lot. I mentioned deeplearning.ai. They actually have quite a number of different courses that are available today. So if you haven't already put yourself on an AI learning path, I highly recommend it. In fact, of the 6 steps that I'm going to share with you today here for how to survive the AI testing apocalypse, if there's any one step, let's say you only want to do one step. If there's any one step that you do, this is one of the most important ones. So try to get yourself on an AI learning path, okay? At the very least, there is a very new course that actually just got created recently from deeplearning.ai called AI for Everyone. It's a course that you can take for free. It's a 9-hour course where they talk about what AI is, they talk about how to build an AI project, and they also talk about societal implications for AI and for this technology. So there's no excuse. It's free. It'll take you a day if you watch all 9 hours of it in one day. So I highly recommend it. And if you want to go deeper into this stuff, then take a look at some of the more technical courses that are offered by deeplearning.ai or Coursera or Udacity, where they have nano degrees on this stuff. So please take a look at it and start learning. It's actually really fascinating when you actually sit down and start looking at it. And if you want to go deeper, there are a number of books that you can look at. And if you're interested in the theory, if you're interested in a lot of the mathematics that power these systems, then these are the places to go. And I also encourage you all to stay up to date, up to speed with the work that all of these companies are doing and other companies in the testing AI space. Try to get your hands on these products. Try to use them, because it's actually very possible that you can become an AI Sherpa in your own organizations so that you can bring this technology back to your organizations so we can start using this and start learning and start contributing to it. All right, this is one of my favorite ones. Choose your weapons, okay? Let's deal with the zombies. So figure out your weapon of choice for the zombie apocalypse. The best way to kill a zombie, sorry for the gory detail, is to decapitate it, okay? So take an axe, take a sharp knife. If you've got a samurai sword, samurai blade lying around, use that, okay? That's more effective. And you can never have too much ammo, okay? So for the AI testing apocalypse, figure out your weapon of choice. It's the same thing. There are plenty of tools out there. Whether you're just getting your feet wet for the first time and you haven't actually used this technology yet, or you're an expert and you've already been using it, there's something out there for you to continue advancing and to get started. So I'm going to present to you with the first tool, the first weapon of choice. Call it the AI fidget spinner. I can't take credit for this, actually, because I was actually working on the presentation and my wife looked over my shoulder and she says, "That looks like a fidget spinner." So I'm like, yes, I got to use that. That's the AI fidget spinner. So thank you, Yesenia, who's actually here. So machine learning, this is more of a conceptual kind of weapon, so to speak. So machine learning is really three major areas. So there's unsupervised learning, which really thrives on data that is not labeled. There's supervised learning, which thrives on data that is labeled. And then there's reinforcement learning, which we already talked about a little bit. So this really helps me kind of keep these things organized and understand what are some of the use cases for each of these sub kind of technologies in the field. So it's kind of like a mental model for how to think about this technology and how to approach it. Google's doing some really exciting research on what they call AutoML. And it's basically, it's LTL, or learning to learn. So they're actually building AI that builds AI. So they have AI, it's really meta. They have AI that actually builds AI for you, okay? So there's something called AutoML Vision, which is what you see up here, where you take all the images. So imagine you have your own training data set, your own data set, where you've labeled those images. But you don't actually have the technical expertise to build a neural network or to go out and put these things together. So Google's AutoML, you just go on their website and you upload your data set, and it'll use its own AI to build the best possible AI for your particular training set, given the current kind of known algorithms that are out there. And they have the same thing for text. So it's not just images. So if you have text, maybe requirements for your software, maybe you can kind of massage this information and turn it into a data set. And then you can actually train your own text classifier using their AutoML technology. And then there's this one, which is actually really new. It's called AutoML tables. So if you've got an Excel file lying around, if you've got a CSV file with useful information, useful data that you'd like to use machine learning on, you can use this. You can use AutoML tables, upload your data, and try out the algorithms without having to learn all of this deep technical knowledge about how AI works. Now, AutoML is not going to solve all your problems. There are a lot more algorithms out there than AutoML can do today. But at the very least, it's a good starting place for you to actually get your feet wet and try to use this tech yourself. And you might be thinking, well, this is AI that builds AI. How good is it? How does it compare to data scientists? How does it compare to machine learning engineers whose job it is to build these models? There's some research that actually shows that AutoML for some problems exceeds the performance of the best models that human data scientists and machine learning engineers were able to put together. So the AI that creates AI is better than the people creating the AI. So in terms of applying this stuff to testing, myself and my colleagues at Ultimate Software did some work on creating a notebook, a Jupyter notebook, which is a dynamic notebook where you can install it on your computer. You can follow along, and it's basically a tutorial that teaches a lot of these concepts. And it also has examples, code examples that are interactive, where you can actually run the AI and see the result right away in front of you. And there are also a couple of exercises on applying it directly to testing. So if you want to check it out, tinyurl.com/notebookaist. We've also done some work on, we've open sourced some work on Agent and Agent X, which is basically a test bot that crawls through an application, and it's a proof of concept that crawls through a web application and does some basic testing. And then we've released a companion system called Agent X, which is a Chrome extension that allows you to train the system. And I know Test.ai, one of the companies that's really working in this space, has also open sourced some really useful tools. One of which is an Appium plugin that allows you to use AI for element selection. They have the code for that available for you. And you can also look at Classifier Builder, which is code that allows you to, open source code that allows you to build your own AI classifiers that then you can plug into the Appium plugin to actually do this stuff. Okay, so step number 4, getting to the finish line here. Avoid dense population. So what does this mean for the zombies? Let's get back to the important stuff, zombies. Okay, so get out of highly populated areas, especially anywhere close to a city, hospital. That's where all the sick people that got bitten go to. Get away from that. What does this mean for us in testing? Get out of the highly populated areas. There are certain aspects of testing that are going to get automated first, and there are some aspects of testing that are not going to get automated anytime soon. So why don't we let the AI swarm on the areas that we know it's going to be good at, and why don't we step away and focus on the areas that we know we're better at, and the AI is not going to be good at anytime soon. So if you really think about software defects, you can kind of more or less classify software defects into one of these 5 categories. Superficial defects are ones like the application crashed, or it just unexpectedly closed. Patternized defects are ones that could be found through using techniques like boundary testing. The third one, expectational defects, are things where it's a deviation from some norm. So for example, if you're checking out from a shopping cart and the application asks you for your credit card information, we've used so many applications already, and we've gone through that process, at least most of us, so many times, that we have certain expectations of how the application should behave, even if we've never seen this new particular application. So credit card numbers should be validated. There should be an error message if it's incorrect. That kind of stuff are expectational type issues, deviations from that. Then you've got the functional failures and also the deeper issues. So these are things like making sure that the software adheres to the requirements and the specifications. And looking for deep issues like concurrency problems, in some cases performance problems. So if you really think about it, most software testing defects fit into one of these 5 categories. And all I'm saying here for this particular point of advice is let the bots take over the top part of the screen. They're going to be okay with superficial. They're going to be able to find that stuff. They're going to be able to apply patterns to find different types of defects. They're going to be able to learn from the behavior of many applications. And they're going to be able to tell you if you're deviating from some norm. But they're not going to be able to tell you some of these deeper things, like does it adhere to the requirements, the specific requirements for this particular application. At least not anytime, at least not yet. We'll probably get there, but at least not right now. Step number 5, assemble your team. Zombie apocalypse, okay? We need a strong leader, a medical professional, someone who is wise and can give good counsel, a warrior to protect the people, a caregiver who can comfort everyone when things are looking down, and someone who can provide comedy to the group, comedic relief, right? What about for the AI testing apocalypse? It's no different. We need to assemble our team. We cannot work this problem alone. We have to work together. And there are actually already associations like the ASTA, AI for Software Testing Association, founded by Tariq King and Jason Arbin, who formed a community around this and who send out newsletter on advances to testing and AI in testing. So if you want to get involved, one of the things that I encourage is to actually do so. Get involved, sign up for the newsletter, and start working on some of these problems, because a lot of the times when we start working on these problems, we'll share it with the newsletter, and it's an open source way to work on AI for testing. All right, step number 6, make a good stronghold, okay? So for the zombie apocalypse, this just means we need to make sure we find shelter, and we make a good stronghold. We want to make sure that that stronghold has a good supply of food, good supply of water, and also that there's some vantage point where we can look 360 degrees, make sure no zombies are coming. For testing, this is really going beyond the individual, and it's really to start thinking about the organization. Okay? So just like my message to everybody here is you need to make sure that you're on an AI learning path, and you need to make sure that you're starting to try out this technology for yourself. I have similar advice for organizations as a whole. You need to embrace this technology, and you need to take risks. So if you're a leader in your organization here today, I strongly encourage you to go back to your company and create the space for this to happen. Create the space for your testers to innovate and for your testers to actually learn this stuff and to try this stuff. And let them fail, because they are going to fail. But when they actually succeed, then your organization is going to propel forward. So you're going to reap those benefits. So let's summarize. Prepare your kit, keep in shape, choose your weapons, avoid dense population, assemble your team, and make a good stronghold. So my question to you is, are you going to survive the AI testing apocalypse? And are you going to thrive in the AI testing apocalypse? And I think we need to muster as many of us as we can for this mission, because there's an even greater challenge that's ahead of us that some of us may not even be aware of. So I talked about the fact that AI can automate some of the testing that we do today, but even if it gets to the point where it can actually automate all of the testing that we do today, this super massive explosion in AI and the proliferation of this technology is creating an even bigger problem that is really subtle at the same time. And that problem is, how do you test the AI itself? Right? So you've got AI building AI, right? So how do you test the AI that builds the AI, let alone the AI itself, right? So we've got self-driving cars. We've got so many applications of AI. How do we test that software? And if we actually do manage to get to the point where we build software that has superhuman intelligence, how do we make sure we test that so it doesn't take over, right? So it's really important for us to really think about this problem and to not be scared about AI and testing, because AI and testing is actually a good thing so that we can have more time to focus on this problem. So I'm going to leave you with one final quote here. Deep learning is a superpower. With it, you can make a computer see, synthesize novel art, translate languages, render a medical diagnosis, or build pieces of a car that can drive itself. If that isn't a superpower, I don't know what is. And this is also from Dr. Inge. I happen to think that testers, all of us here, are superheroes. Or at the very least, we pull off superheroic efforts, even under extreme time constraints, even when sometimes we're considered the underdogs. So embrace this superpower and let it help you, because we're going to need help. So I know that AI is here. I know that AI is everywhere. I know it's important, and I know it's not going anywhere, but guess what? If we follow this advice, neither are we. Thank you.